Okay, so let's graph number 1. 0, 2, 1, 1, 2, 0, 3, 1, 4, 2. Okay, so it's pretty clearly absolute value. It's a V shape. Okay, so comparing it to the parent absolute value function, the vertex got translated 2 units to the right. So h equals 2. So y equals absolute value of x minus 2. Okay, and then number 2. Okay, -1 is undefined. 0, 0, 1, 2, 4, 4, 9, 6. Okay, so, well, I noticed that the x values are all squares, right? 0 squared, 1 squared, 2 squared, 3 squared. And then I can also see the graph is leveling off or increasing slower. So that tells me the square root's probably involved. Okay, so I might start with square root of x. Okay, well, if I just plug it in, if I plug in x equals 1, the answer is supposed to be 2. Okay, square root of 1 is 1. Okay, and then how about 4? When I plug in 4, square root of 4 is 2, and I need to get to 4. So if I multiply by 2 in front, that should make everything work. Okay, problem 3. -1, 6, 0, 3, 1, 2, 2, 3, 3, 6. Okay, it looks quadratic, so let me check the second difference. Okay, so I do have a constant second difference, so it is quadratic. So I know quadratics look like this. And then because the constant second difference is 2, I know a is half of that, so 1. And then I know from the y-intercept that when x is 0, y is 3. So c is 3. Okay, so 1 x squared plus bx plus 3. So let's just plug in a data point. Let's plug in when x is 1, y should be 2. Okay, so 2 equals 1, and then plus 3, so 4. And then plus b times 1 is b. So b is -2. So putting it all together, we have ax squared, a is 1, so just x squared, plus bx, b is -2, so minus 2x, and then plus c, c is positive 3. Okay, number 4. -3 5/3, -2 3/2, 1.5, -1 1. 0 is undefined. 1 is 3. 2 is 5.5, or excuse me, 5 halves, which is 2.5. 3 is 7/3, which is 2 1/3. Okay, so I don't have enough data points, but I'm pretty sure it'll look like this. Okay, so I'm looking for a rational function because I see I have both a vertical and a horizontal asymptote. Okay, so, well, using the fact that 0 is undefined, I know that the denominator, when x is 0, the denominator is 0. So I should start there. Right, 'cause now when I plug in 0 for x, that leads to undefined. Okay, so now looking at some of the fractions, it also matches, right? When x is 2, the denominator is 2. When x is 3, the denominator is 3. So how do I get to the numerator? Well, 1 turns to 3, 2 turns to 5, 3 turns to 7. So you're doubling the x value and adding 1. Okay, let's move on to 5. Let's see. -2, -3/4, -1, -1/2, 0, 0, 1, 1, 2, 3, 3, 7, and then another point even. Okay, well, this looks exponential to me. Okay, so, well, let's examine the differences. We have, I'll skip the fractions, +1, +2, +4, +8. So these are all powers of 2. So 2 is involved. Okay, so let's just plug it in. When x is 1, 2 to the first power is 1, but, sorry, 2 to the first power is 2, but it's supposed to be 1. When x is 2, 2 squared should be 4, but it's 3. When x is 3, 2 to the third power is 8, but it's supposed to be 7. So it looks like we just need to subtract 1. Okay, let's get 6. Okay, so let's see, we're working with radians here. Okay, -3/2 is 2, then 1, then 0, then 1, then 2. Okay, so looks like we got either sine or cosine here. Right, it's periodic, and makes more sense to use sine because the initial value is at the midline. Okay, so the period from bottom to bottom, the period is 2 pi, so there's no b, or the b value is 1. The amplitude, well, the midline is 1, so it's just 1 unit up or down. The amplitude is 1. But then the midline got shifted up 1 unit. Okay, moving on to 7. Let's see, so those are some big numbers. -7, -2, 0, -1, 1, 0, 2, 1, and 9, 2. Okay, looks like cube root to me. Okay, so what do I know about cube roots? Well, what numbers would be easy to cube root? So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. So instead of using the easy to cube root numbers, we're given, well, 1 is there, but let's also put in 0 cubed is 0. Okay, so for example, 27 doesn't show up, but 28 does, and 8 doesn't show up, but 9 does. So it looks like we're adding 1 to the number which gets cube rooted. Okay, let's plug in a point when, oh no, sorry, we have to do it the other way because we're inputting this, so to get from 28 to 27, we have to subtract 1. Okay, I'll just start over. Okay, so plugging in let's start with 9 actually. So plugging in x is 9, 9 minus 1 is 8, cube root of 8 is 2, and that's what we wanted. So it doesn't look like we need to do any other transformations. Okay, 8. Let's see, we got some big numbers again. Okay, so -212. So why don't we scale by 4s along the y-axis? Okay, so -212, -1, 0, 0, 2, 1, 0, 2, 0, 3, 8. Okay, so it looks like we've got a polynomial function here. Okay, so what do we know about the zeros? There's a 0 at 1, excuse me, -1, so x plus 1. We have a 0 at +1, and we have a 0 at +2. Okay, so based on the points, these are all multiplicity 1 because they all go straight through. They don't bounce or wiggle through. So we can just check a point. So why don't we check if 3 really leads to 8. So 4 times 2 times 1 is 8. Okay, so it seems like this is correct. Okay, let's look at 9. 1/8 -2, 1/4 -1, 1/2 0, 1 1, 2 2, 4 3. Okay, so we've got a vertical asymptote, so it's looking logarithmic. Okay, looking at the x values, we're multiplying by 2 every time. 1 times 2 is 2, times 2 is 4, times 2 is 8. So it's probably going to be log base 2. So let's try 8. Log base 2 of 8. So 2 to what exponent equals 8? That'd be 2 to the 3rd power. So since it's a 4, we must have added a 1. Well, but instead of 8. Alright, so we can just check it right here. 4 equals 3 plus 1. So the general function, you do log base 2 of your input, and then you add 1 afterwards. Okay, so remember, without the parentheses, you do the log first, and then you add 1 to the result. Okay, let's look at 10. -2, -5, -1, -3, 0, -1. Okay, so it looks like this one is going to form a straight line, so it's linear. So the slope is to go up 2, you go right 1, so slope is 2. You could also just do the first difference. And then the y-intercept is -1. Okay, let's look at 11. Okay, -4 is -2, -3 is also -2, -2, -1, -1, -1, 0, 0, 1, 0, 2, 1, 3, 1, 4, 2. Okay, so this is looking like a step function. So this one's kind of tricky because the steps are going to be more than 1 unit long. So in order to, because we know the domain for step is all real numbers, so based on how steps look, we can figure out it would look like this. Okay, so each step is 2 units long. So in order to do a horizontal stretch to make the steps wider than normal, the input must have a, it must be a fraction. So just like for the trig functions, when the b value was a fraction, it made it wider. So this is a floor because we're rounding down. The filled in dot is on the right. So floor, and then the steps are twice as long as normal. So over 2, and let's see, when we plug in 2, 2 over 2 is 1, floor of 1 is 1. When we plug in 3, 3 over 2 is 1.5, floor of that is 1. So it seems like that was the only change. Okay, last one. So we're dealing with radians again. Okay, so negative pi over 2 is undefined. Positive pi over 2 also undefined. 0 is 1. Pi over 4 is 2. Negative pi over 4 is 0. And we got some other points. But it looks like we have a tangent graph, but instead of a point at the origin, it's at 0, 1, so it's been shifted up by 1.